Harbin Institute of Technology, Shaohui Liu, with the lecture about deep learning in computer vision sphere. Please welcome our professor.
Okay, welcome to Harbin, and I'm very glad to see you. And today I will give a basic talk about the deep learning driven CV and video quality assessment. My name is Liu Shaohui. This is my email, and if you have any question, maybe after finish this talk, you can send the email to me, and we can discuss it in detail. And I come from the computing faculty of Harbin Institute of Technology. Okay, the main content includes this part. The first is I give a basic discussion about AI and deep learning, and then I talk about a little about the traditional CV and the deep learning driven CV. The third, I will give a discussion about our recent papers. And finally is the conclusions. Okay, in China, AI has become a national strategy from the government. Give many documents to help people to understand the AI and the importance of AI and utilize the AI technology to improve the efficiency of production and industry and so on. So actually, this is the said JAMA from our JAMA. Artificial intelligence is the new round technological revolution and the industry transformation, an important driving force. And actually, external information received by humans in most of depends on the 5 senses. Is vision, hearing, smell, touch, and taste. Maybe most of it is based on the vision. It's maybe 18.3%. And this is very similar to the traditional Chinese medicine. In Chinese, maybe 望闻问切. The basic meaning is similar. And the main research content of the artificial intelligence is to develop some human-like perception, and especially for perception of the environment, and to get it to do some works. So we should to need the machine just to learn and to solve perceptions of the environment. But after all, maybe the computer vision and the NLP, natural language processing, are the 2 main achievements in AI. For computer vision, is to make machine have a visual system like the human eyes, and will be automatically understanding the external environment, and further expand to be able to perceive and understand the environment through multimodal sensors. And the natural language processing is to enable machines to have the ability to organize and use language like humans. But depend our belief, the intelligence should be for good, but for bad. So according to our understanding, maybe the AI should be useful in the lab production and the exploration of the uncharted. This is for the lab. The main function maybe is to improve the capabilities index of lab. For example, maybe depend on the AI, you can design some games, maybe you can give some music, maybe help you to sports, and maybe you can give you some experience on the entertainment. This may be needed to many AI technologies. And the second major is about the life is maybe the medical care and elderly care. So this is used the AI technology to solve pain points and the difficulties. This is in the lab. And the second, maybe AI is useful in the produce. The main is to increase the productivity levels. The AI should be useful. And maybe improve the quality, the production quality, maybe increase the efficiency and the effectiveness, and to promote the social development. This is the second, maybe, main concept. And the third maybe explore the unknown. Because the uncharted territory, for example, deep earth, and the deep space, and also maybe deep sea. This area maybe for human is very difficult to achieve there. So maybe we should design some AI technologies to help our humans to discover some materials. Okay? And the second maybe unknown mechanism, for example, maybe human beings. Even are human beings, but we don't understand in detail our human beings. So there are many difficulties to with our explore. For example, the brain's genetics, and from the macro and to macro and so on. So, based on our understanding, maybe AI let people better realize their spiritual pursuit and the self-worth in the process of the creating wealth. And then maybe accelerate the construction of manufacturing power, accelerating the development of advanced manufacturing, and promote the deep integration of the internet, big data, artificial, and cloud and technologies. And after maybe the 2024 Nobel Prize is for the chemistry and for the physics is all about the AI. So this is also to propose the AI interest in harm people, especially for the chemistry. It may be announce the beginning of the new era of AI plus science, maybe in short for AI for S. And this is a basic description, but actually in chemistry use the AI to predict the protein structure. And the physics is also based on the machine learning, based on artificial neural networks. So we understand that AI is very important, but actually AI has different levels. Maybe some people think AI maybe is only the weak, maybe means the narrow, and maybe AI will be strong, will be super. Yeah. So for weak AI, maybe N is means narrow. The artificial intelligence that accomplishes the specific task, act as it is control agent. Not self-aware, and it does not threaten the survival of humanity. At present, more and more weak artificial intelligence has been realized. Now, up to now, maybe most of AI technology is weak artificial intelligence. And the second is maybe called as the strong AI. Maybe we hold it the AGI. G means the general. So artificial general intelligence, maybe machine have real reasoning and problem solving abilities, and have the same possibilities as human to do all the work. And maybe it's the expectation of our human being. And it will pose a threat to the survival of humanity. But there is no possibility of this for the time being. So maybe many decades, there will be some strong AI. And the last is super AI, maybe ASI. Super AI refers to being self-aware, including dependent values, worldviews, and so on. And much smaller than the brightest human brains in almost every field, including scientific innovation, and general knowledge, and social skills. So some people may be thinking many of the weak AI technologies may be equivalent to the strong AI, but in fact, there is not the equal. Even many weak AI technologies is a clear gap for the strong AI. And now, we all know the natural language processing have a very good capabilities in some works, and maybe it obtained the good capabilities more than 100 data sets. But actually, the natural language processing is also the weak AI. So coding some papers, maybe there are classification for artificial general intelligence is called the AGI. We give the basic classification, and the rules is about performance. Maybe we can call the narrow AI, is weak AI, and the most color is maybe the strong AI, the general AI. So maybe hold it for the 6th level. The first level is called the level 0. No any AI. And just like the narrow AI is called this one. AGI is for the general non-AI. Maybe people in the group. And the first level, maybe what is the zero level, this is the first level. Maybe we call it the emerging able to somewhat better than an unsteered cube. So for weak artificial intelligence, maybe we call it the narrow AI. For example, maybe some export system and so on. And for general AI, maybe emerging AGI is called maybe called ChatGPT, Llama 3, and maybe DeepSeek. And this is the current research topic about the large language model. And this is current topic research is only the realization of the first level. After that, maybe the second level is called the computer, at least 5% of steered adoption. And for the narrow AI, there are computer the narrow AI, maybe policy detectors such as Jigsaw, smart speaker such as Siri, Alexa, and Google Assistant, and the Wiki system, and WhatsApp. And some for the specific subset of LLM for short essay writing and simple coding, maybe is code for the level. But for AGI is not. And the third maybe the export level, at least 90% of the steered adopted. And maybe for TOEFL, the fourth maybe at least 99% of the steered adopted. This is the level the current AI has reached. We only for this one. Actually, maybe the last level is the superhuman outperformance. 100% of the human. So, but for the narrow AI, maybe some calculation, for example, the AlphaFold, Nobel Prize, AlphaZero, calculation, and so on. But for the general AI, this is not solved. So for the computer vision, we hold the CV. CV is very important and is the maybe the most useful in the AI technologies, and has important application in civil and model defense field. There give some examples for the life and the entertainment, the safe city, smart manufacturing, smart education, unmanned devices, the smart finance, and the smart care, and the aerospace and defense, and so on. Many fields, maybe there are CV applications. And for the main problem, maybe the representation and the learning of visual features is the key to the CV. This is a simple example. This is an elephant. Maybe different people maybe touch the different part of the elephant. Maybe each people has different feelings. And maybe he thinks this is a special bird. But actually, it is the same elephant. So we should give some enough feature representation and learning, and some maybe algorithms and architectures, and then maybe can, according to the visual features, to do detection, classification, regression, and recognition, and so on, many other CV tasks. But maybe some people are familiar with the natural language processing. Maybe you find that for NLP, maybe have some common foundations. And if you give the large language model, maybe you can do most of the NLP tasks. But for vision, it's not the same. So many people think the CV is more challenging than the NLP. So why do we think the CV is more difficult than NLP? Anyway, can give some explanations? But maybe, I think maybe the NLP has a clear bottleneck. Different words should be arranged some predefined rules, and then it may be take some semantic meanings. But for image, it's not the same. Anything, maybe you can take a photo, maybe this is an image. So maybe the number of the image should match than the number of the text. So the borderline of the image is not clear. Anything should be an image. But the text, but the natural language is not the same. So the NLP should be easier than for CV. And also for natural language, there are many large language models. But for CV, maybe is a very challenging task for you to design a large vision model. Maybe you can consider this problem, okay? And traditional, maybe we can to do the AI. Maybe several decades before, maybe some do AI, maybe it clearly includes the machine learning, and the pattern recognition, just two parts. And many maybe based for the speech processing and the image processing, maybe the key, maybe the all of the AI. So for CV, is only these places. This is the CV. And according to the CV, maybe different brushes. For example, maybe multimedia and Kuma computer interaction, robotics, and maybe visual environment, maybe digital twins, and maybe human computer and biomedics and psychology and so on. For according to the MAR, maybe 3 level of computer vision, maybe the low level and the mid level and the high level computer vision. And for example, maybe some objective maybe can image, and maybe include the camera model, lighting, color, texture, motion, shape, and so on. and then we get the image and the video. According to the image and the video, we can do some text analysis, and we have to do many low-level image processing, and maybe have to do the color analysis and motion analysis, and maybe some point detection and edge detection, and maybe corner detection and structure detection, and so many computer vision tasks. And based on them, maybe have to do the object detection, object tracking, and the understanding the behavior and so on. So actually, maybe 15 years ago, there is no deep learning. We also do the same computer vision task as now. But maybe most of the students maybe don't know the details in the no deep learning era. People how to do the computer vision tasks. Because now we only collect some samples, and maybe we can train model and give the input, and we can obtain the output. And we can adjust the architecture, and we can construct some neural network architecture, and maybe we can get the result. So maybe should to think. So for the traditional computer vision, maybe there are some basic pipelines. Firstly, for the traditional CV, there are many properties, For example, maybe the traditional CV tasks is no energy cost. Maybe need no computing power. So it can be used many of the embedded devices. But I have to know, for deep learning CV, maybe most of the algorithms should be high energy cost. Maybe need the high computing power, and maybe it's very difficult for the edge employment, and so on. This is the basic pipelines for the traditional CV. If you give the input image, maybe we can do the edge response, because we know the edge is very important to recognize this object. So we design the edge response. And maybe we can design the color response, because we know the color is also very important for our humor to perception the object. And many similar ideas. And then maybe we can code we can collect the many the non-level feature. And then we can aggregation of this non-level feature become a vector. But this vector maybe represents a different part of the object. So maybe we know the specific local features, and maybe we require some global features. So we can, based on the aggregation, we can get the global descriptions. For example, the histogram. And then maybe we can get the LBP, local battery patterns, for the recognition. And then we can also aggregation of this local and global vectors into the feature vector. And then finally, maybe based on this feature vector, we can do the CV task case. So compared with the deep learning CV, maybe similar, but maybe only focus on this way. Machine learning model, maybe if you have get some features, maybe you can use the machine learning model to do some work, maybe to train and so on. But deep learning based CV, maybe all of procedures maybe combined into the architecture, neural network architecture. But which is better, maybe different people have different viewpoints. But based on our experience, we think for weak artificial intelligence, maybe most of the traditional CV solver is enough. This is deep learning, maybe you put a car and you can train many convolutional kernel and extracting one level and another level and another level, and then combine all of the level into the final vector, feature vector, and then give the output. But it's obvious because our human being capabilities, maybe we can handle 2 or 3, 4 levels. But for deep learning pipeline, maybe he can combine many levels to do that. And another viewpoint about the computing power, up to now, maybe many people, many students, maybe to do the research. Maybe the first question is, we don't have enough computing power, so I don't do this task. We don't have enough power, so I don't train the model, I don't to do any computer vision task. This is the basic difficult. For this one, this is the training power, petaflops. And for this one, total, and maybe proposed many different models. This model maybe the basic requirement is the computing power. So for most of us, maybe we connect some computing power to do our research. So for AI processing, there are also the basic procedures. Maybe we think for up to now, the AI is deep learning, because everything can be learned by the deep learning method. So we have to learn deeply anything. But from the basic, maybe the basic procedure is just the same as the traditional CV. For example, you also need to import the data, maybe video, text, or other different type of data. But all of this data should be transformed into the numbers, vectors, matrices, or tensors, and so on. And then we also to do the basic procedure for reduce the dimensions, and this to do some mathematics, maybe simple, maybe complex, and finally maybe output any you expected the data. Of course, if you give the model, you should to do the test. to verify the performance. So, if you look at this figure, maybe you can find there may be many models for this one. The deep learning is not only to design the architecture. It's not only to connect some samples and then training the model. Maybe you have to do more works on the deep learning CV tasks. For example, maybe you have the deterministic models, maybe training functions, maybe the loss function you should to optimize, and so on. But maybe people don't care this part. They only like to connect samples and to train the models. And maybe some proper web-based models, JPG, and make nice like code. So we give the first question. In AI era, what do we learn in our university? We to learn the basic model, maybe the basic architecture, or some others. Maybe we to learn how to collect data, and we to learn how to modify some open source code. Maybe you can think it. Maybe you can import any data, and then maybe you can machine learning models, and maybe deep learning network. Maybe all of this task maybe have some open tools. Maybe you all need to learn how to master these tools. I think maybe you should to learn how to design these tools. You to learn the basic, the background, and the mathematics of these tools. So according to the Domingos, this is a fellow and a professor of Washington University. It means that the machine learning may be equals to representation plus optimization plus evaluation. If you only to learn the tools, maybe it's only to superficial AI research. So from the traditional and deep learning paradigm, maybe we can to learn about the mechanism of the human vision system. And then maybe we can get some mathematical representation, and maybe we get the sparse and low ranking representation, and finally maybe give some modeling. And this is the traditional processing. But for deep learning era, maybe it's different. For example, maybe we can the image, and we can get the digital image, and we design the architecture, and we import the picture, and we can obtain the output. But this maybe some objective cost function, and maybe we plus some regularization, and some maybe prior our human plan and so on. And then maybe we do some research. Of course, if you get the last function, maybe you should to do some optimization. If you solve the optimization problem, and then maybe the final, you should to do the evaluation. So we have the second question. Why can deep learning learn anything? Because no. Some people may be thinking, all the machine learning may be deep learning, and maybe deep learning can learn anything, and we can only to collect some data, some samples, and we can use the open source code, we can to train the model, and we get the result. So we talk about the approximation in machine learning. Actually, maybe several hundred years ago, maybe the approximation theorem, the first theorem maybe was last. There is a function fx belongs to the interval, this one. These are continuous functions in the interval A to B. Then for any given epsilon larger than 0, there exists such a polynomial px such that px minus fx. So makes the difference should be less than epsilon. It means that we can use the polynomial to approximate the function. Maybe the function may be the discriminant function. And this is called the Weight-First theorem. You can, the proof is simple. Maybe you can construct a series of polynomials like this one. This is called the Bornstein polynomial. And then you have to prove this called on the interval. This is for this type of continuous function. And for the theoretical continuous function, maybe we can construct some trigonometric polynomial functions to approximate the function. This way, just like this. So if the coefficients are an and the bn is not all 0, then this tx is said to be a trigonometric polynomial of order n. And for the periodical function, maybe have the second theorem with us. Suppose fx belongs this one. This is a periodic function. Then for any given epsilon larger than 0, there exists trigonometric polynomial tx such that this hold. It means that we use the trigonometric polynomials to approximate any functions. The proof is also very simple. But from this one, we can find that the mathematical thinking, this is approximation, is transformed into a computational think. Actually, we can construct some polynomials to approximate the function, any function. So the mathematical thinking is transformed into the computational thinking. You can use code to achieve this goal. But we talk about the deep learning can learn anything, maybe the traced to the 1989. Seminar gave a simple discussion. Maybe a number of diverse application areas are answered with the representation of given functions of an n-dimensional real variable by finite linear combination of the form. Just like this one. And this is a similar the activated function of a neural network. It's just like this formula. So here the univariate function sigma depends heavily on the context of the application. And that major answer is with so-called sigmoidal function. Just like it. This formula, st to infinite, then maybe sigma t should be approximate 1, otherwise should be 0. Such function arise naturally in neural network theory. As the activation function of a neural node, and the paper has shown that the sums of the form, this form, are dense in the space of a continuous function on the unit cube. Only requirement the sigma is any continuous sigmoidal function. So we could give a theory for universal approximation theory. It denotes the n-dimensional unit cube. The space of the continuous function on n is denoted by this sign, and we use this to denote the superring, maybe some kind of norm. And the universal approximation theory is just like this one. This sigma should be any continuous discriminant function. Then the finite sum of the form are dense in C and N. In other words, give any function in this type of functions. And if shown there larger than 0, then is the sum gx of the above form, this form, for which hold. This communal function is just like this one. This is the definition. If applying the UAT to the case of most trace in neural network theory, then we give the similar theory. Networks with one inter-layer and an arbitrary continuous sigmoid function can approximate continuous function with arbitrary precision, providing that no constraints are placed on the number of the nodes or the size of the weights. This is a formal representation. Just this, like this one. So if the function f, this f, maybe a decision function, it means that this decision function can be implemented by a network with a single intel layer. So according to this, maybe you can then realize that the computational sink is transformed into deep learning sink. And this gives an example. Using the simple neural network, we can approximate the step function, just like this one. This is a basic 3-layer neural network. One important node, two casing layer node, and one output layer node. And then we can approximate this function. If we adjust the weight, and then we can get more function. And if we adjust the weight, we can approximate use this neural network to approximate this function. And also we can increase the number of nodes in hidden layer. We can get this one. This is also 3 layer. We can get this one. If you get this rectangle, maybe you can approximate any functions. So according to our intuition, maybe the neural network has the capability to approximate any functions. So there are question. Since a 3-layer BP network can approximate any decision function, why are deep learning neural network popular now? Deep learning may be more layers, more than 3, maybe 100 layers, 1,000 layers, such as the ResNet and so on. Yeah, okay.
Well, I guess it also depends on how many, in each layer, how many neurons there will be. It would be just too large. Maybe you could reduce the number of neurons in each layer, but increase the number of layers. I don't know, just
Yeah.
the same.
Yeah. So maybe you, yeah, okay.
Just because creating more layers is more effective.
Mm-hmm.
You can approximate any function with 3 layers, but you'll learn it too long.
Yeah. Yeah. It's very good. So if you only 3 layers, maybe you need many nodes, and it's very difficult to train such a model. Maybe. So this will give you this. If you suppose we give you a arbitrary network, the weight and the number of the nodes are fixed. Then is a model. Then you can generate infinite number of samples. You give 5 input and you will get the 4 output. So there is a sample. Maybe you can get the infinite number of the samples. But the problem is, can you train each network exactly the same network again? Because the number of the sample are infinite. Can you train the same model? Actually, this is a difficult task. But if you only finish out this communal function, maybe you can increase the layer, the number of layers. And then maybe the task is changing into easy to do your with. According to our research experience, so the traditional CV tasks are fundamentally important for deep learning-based CV. And the first may be the resource of innovation. And many of the innovation in deep learning is come from the traditional CV method. The second, many methods are strongly supported by the mathematical principles, especially for traditional CV. However, deep learning needs only samples. If you do not know the principles, then you would not modify the architecture. Maybe you only use the open source code, and it's not possible for you to design a new novel architecture. Because such new novel architecture usually come from the traditional CV pipelines and from the mathematics in the traditional CV. But our students maybe don't care the traditional CV. Even for the course, maybe they think this is too old. We give some basic examples. Firstly, maybe the multi-resolution theory. This is traditional multi-resolution theory. Maybe we call it the multi-scale. In image processing, maybe we call it the pyramid. But according to the pyramid, we can design the FPM and the UNet. Most of people will know the UNet is the where common used neural network for segmentation. Second is the local and the global. Because in deep learning, the convolution is usually a local processing. So even the beginning of the deep learning, many of people only use the convolution to deal with the import. And usually it needs much more layers to get the global information. But up to now, some people maybe design some architecture, including basic two brushes. One is to do the local processing, and one is to do the global processing. Maybe the import image should be transformed by mathematical transform, and then to do some following procedure, and get the global information. And for the APCM, DPCM, adaptive prediction, parse modulation, and so on, maybe can design the resonate. Because the difference is very lightweight to deal with. And maybe we, from the handcrafted feature to get the learning-based feature, and so on. And we give a in specific description about the multi-resolution theory. In 1987, WebNet are shown to be the foundation of a powerful new approach to signal processing and analysis. It is called the multi-resolution theory. It's come from the sub-band coding. Maybe we heard from the quadrature mirror filtering from the digital speech organized, and maybe heard the pyramid image processing. And all of about the multi-resolution theory. And finally, it combines all this discipline and it design the WebNet. And the WebNet can be easily represented from the subspace. And we can decompose the space into subspace. And each subspace may be called the WebNet space. It can decompose perfectly space. And this is the care scanning function, and the care WebNet function is used the average sum of two input. This is the difference of input to value. And then combine this with, and we have the original signal. But this algorithm can be implemented by the first algorithm. We call it the magnetic algorithm. It's just like the Fourier transform. We use the FFT to do the transform. And this is for the two-dimension subspace. We can send to do the decomposition. This is an input image. Maybe we do whenever WebNet decomposition, we can get this full subband. And this is an input image. We can get the full subimage. And this theory can be extended to much more filters. Multi-direction decomposition. This is just like the deep learning method. Because each of the subband is get from the input image with convolution or convolution kernel and get the subband. And this is one level WebNet decomposition. And this is two-level decomposition. And this is n-level decomposition. And this is the care basis image. And this is very simple because we can learn it in the linear algebra. For 8 by 8, it's totally 64 dimensions. So there is 64 bases. And obeying the multi-resolution, we can give the UNet. And UNet is proposed 2015. UNet is a biomedical image segmentation. That is well-known segmentation. It uses the data augmentation and the basic architecture. The basic idea is similar with the multi-resolution theory. And the result is very competitive. And this is significantly better than the sliding window convolution network result. But for the mathematical analysis, the procedure is just similar to the WebNet decomposition. This is a unit. This is well known our students, so we don't target it. This is an encoder, and the left side is the decoder. In addition, multi-resolution theory, there are only other similar ideas. For example, the local and global from the convolution to frequency transformation. And the recently proposed architectures use two approaches. This is just mentioned previous. And ABCM, because the difference is easy to see and learn. And the handcraft and the learning best, maybe anything can be learned, even for optimization algorithms. Because we are not the learn algorithm. The learn algorithm is based on the learning optimization, and so on. So we turn to the second topic is about the video quality assessment. So this is very similar. It's very simple. The last part depends on our published 3 papers. One is CASP 2024, is called in the Korean, and the second is the ACM Multimedia Conference, is 2024, and one paper is the 2025 SCCV, is only accepted and not published. So the left part is based on the 3 papers, and we also give the reference, and you can get the details in the idea. Okay, so the video quality assessment aims to simulate the process of perceiving video quality by the human vision system. Several studies have shown that the judgment made by the human vision system are affected by the video content. This is the video 1, this is the video 2. So the quality should be different, but some algorithm maybe give the equal score. So we give some basic human feelings to support to get the exact, more precision scores for videos. And this is some current VQA methods trying to simulate the perception process of the human eyes as much as possible. But this method mainly focuses on the distortion of the video itself in time and space, and ignores the impact of human feeling on human vision systems. And this is some typical algorithms, and maybe published the SM, MM, ECCV, ECSVT, CVTR, and so on. Maybe proposed many different architectures for video stream, swing, transform, video swing, transform, and so on, and the efficient network, and so on. But this method do not establish a good consistency relationship with HVS, human vision system. So we give some hypotheses. One, human language can describe human feelings as well. And this is because it includes rich semantic descriptions. This rich description can be represented by vector. And the second is the multimodal large model that has a high degree of consistency with human feelings. in the perception of visual system. So we can use the multi-model large model to embed in the vector. The third is the feature extracted by the multi-model large model is related to the human feelings are effective and we create these tasks. This is a cliff model. Cliff is very well known because it is maybe widely used in most of the CV and cross-model CV tasks. So in other ways, our rich vision language pair has demonstrated robust zero-shot predictive capabilities across multiple tasks. We therefore chose CLIP to test our hypothesis, and we give the basic description. And this is two types of text description are designed as a report. Object description and the subjective description is only represented by text. And this text, according to the clip, and we give the corresponding feature vector. And this feature vector may be corresponding to the import image. This is the basic performance of clip for description, bright, contrast, noise, colorful, related to the video quality factors. For example, this is a different type of description, and this is our original score. And this is a different score for the minus representing attenuation and minus representing enhancement. And this is another one. Explore the relationship between clip and the human subjective feelings, including interesting, exciting, depressing, fearful in video content perception. And we can give the more correct score. And we also give the basic framework because the video is very long and the large number of data is challenging for video processing. So we can give some strategy to deal with this problem. And finally, we obtain the video feature process and combine the clip to give the final feature and give the final score. And this is a semantic feature extraction and how to extract the semantic feature. And this is the temporal memory effects because the video is closely relationship frame by frame. And finally, we give some experience. And this is the performance. Different feature extraction method. We can use different. The A denotes use both objective and subjective description. So the performance is mostly best. This is the application study on the text description. You can look at the subjective and objective. Combine subjective and objective description can give the best result. And we also based the observation and we propose the cliff we create. This is published in the SMILES. We also import the video and we can extract the thematic features. And we also combine the spatial and the temporal features extraction. And finally, we give the regression task, give the final quantity score. But in this part, we also provide the thematic feature extractor, SFE model, to enhance to extract more thematic features. And this is some common use data set, maybe many videos. And this is table 1. Our result is much better than SCV 2023. Europe, we give the best result. And this is a fine-tuned result on the different database. And we also give the best result of this different database to do the fine-tune. And this is the flows and the running time. We run the code for 10 times and GPU and the CPU comparison. And this is the two sets of video when use only spatial temporal features as well as use both spatial temporal and thematic features. It's obvious that if we use both spatial temporal and thematic features, the given score is more reasonable than only use one of the features. This is another video quantity assessment, MVQA member. The basic idea is use the member into the VQA task case. And this is the basic description, because the video quality assessment, the challenge is the video, the large data. So we use the member, the linear complexity, to substitute the transform, and we design the sample strategy and combine these two tools, give a more better result. And this paper is published this year, SCV, only accepted. This is the comparison on the GPU memory comparison and the speed comparison, and the GPU memory comparison, and the accuracy of comparison. All of this result, our proposed MVQA get the better result. Member is a hot research topic recent years, especially good at processing long sequence. So we use member in the video quality assessment. Use the members efficiency. The second is the sampling strategy to decrease the complexity and the accuracy of VQA. This USDS is our unified thematic and distortion sampling strategy. This is the basic. Also, use different sampling strategy. The result reflects the thematic content. From this one, we can find that USDS strategy is very effective because it can give the score. But if you directly sample, only use the fragment, the thematic is only a very low score. And this is the MVQA USDS, the architecture. This is the 3D patch embedding. The basic is just like the VIT, but only substitute the member. And this is to test the different sampling strategy. The MVK. This is our strategy. And this is the algorithm for unified USDS strategy. This is the video assessment, and we for the different important types. We use the forward scan, the backward scan is the direction scanning mechanism to improve the performance. This is a mass function. Mass function is the predicted coordinate score is denoted by this, and the ground truth subjective coordinate score is derived by this one. And we can design the motionless induced loss L1 and the linear induced loss L linear. Gives this formula and this formula, and combine this, get the total loss function, just like this one. And this is the first result about video quality assessment. Was a classical and the deep multi-fraction, the deep signal fraction, and we designed the tiny and the middle. Most of the result we give the best result. And this is the second is the fine-tune on the different database. In each, we can fine-tune the result. We also give the best result. Of course, the tiny is a little as this one. And this is the flops and the running time. And this is the experiment. This is give the basic description, semantic analysis experiment. And this is some application study. Okay, we give the final conclusion. First, we introduction to the relation between traditional CV and deep learning CV. Second, we validated for the first time the clip is kind consistent with human feelings in video quality perception. The third, extensive experiment demonstrated that the clip has the ability to collect the human beings and the semantic features. And four, we propose the CNIF VQA, and five, we propose the MVQA. This is the first to apply the state space model. We hold the member to the VQA task and propose the effective sampling method USDS, which efficiently integrates video semantic information. And finally is the reference. And the last 3 papers, maybe we can get it from the archive. And you can get the details, information. And the last paper is only accepted, maybe proposed in maybe November in America. Okay. Okay, thank you.
Thank you very much. The offline and online participants, do you have any questions? Yes. Our volunteer, please provide the microphones.
1, 2, 3. Okay. Thank you very much for the lecture. I have a question about the first part, about classification of AI. It's weak AI, strong AI, and super AI. How do you think how large the models should be in strong AI and super AI? And the second question is the following. We know that in LLMs there is an emergent abilities which we discovered in the very big model sizes, like 10 billions and more. And if we distill such models into, for example, 1 billion model, the emergent abilities will stay. And how do you think if we in any way get the strong AI, for example, it's 100,000 billion parameters, can I then distill it and keep the functions of strong AI in a less sized model?
Problem. But if you wanted to general quality evaluation, maybe it's very difficult. Maybe you can use the teacher-student learning and maybe some specific strategy to do that. But in Europe, the age employment is very difficult.
Okay, thank you. Thank you.
Thank you for your lecture. I saw that you compare your work, MVQA, with Vision Number. Also, have you published the preprint already or not? I see that your paper was accepted to ICCV. Is it published?
Yeah, accepted.
Accepted, okay.
We also publish in the archive.
Okay. Have you compared your work to VMamba? It's a paper that was published after Vision Mamba. Vision Mamba was in November of 2024 and VMamba in December.
Yes, there's many different
and they compared to Vision Mamba and show better results. Have you compared it? No? Thank you.
Thank you, Professor. We have a question from online participant. So today, car cascades are not very popular. Could you please tell more about this algorithm in context of modern detection CV tasks? Modern detection CV task. can you tell it in the mic because we have online participant who wants to know the answer.
Okay. So it seems can be used that algorithm to do the detection, modern detection.
Okay, thank you.
Dear colleagues, unfortunately we don't have much more time for questions, but you can ask our professor maybe 5 more minutes. Thank you very much.